Hello, my name is Jai Suri, and I lead IoT and blockchain applications development in the Oracle Supply Chain Cloud at Oracle.
Hi, my name is Ravi Balakrishnan. I am the director for a wonderful company leading the supply chain.
Welcome to this session, and thank you for joining. In this session, we want to talk about digital transformation in manufacturing, or what we call usually digital manufacturing or Industry 4.0. A critical component of digital manufacturing is the seamless closed-loop digital thread from factory floor to IT applications such as PLM, ERP, etc. Recent advancements in technologies such as IoT, machine learning, AI, and many other areas has made it easier than ever to drive smoother integrations between what we call the OT systems on the factory floor and IT systems within the enterprise. But challenges remain. Many projects end up in what we usually call the pilot purgatory. So let's take a look at what's going on and how they can be made more efficient. What are the primary hurdles in building that seamless digital thread from OT to IT? Has been the disconnected divisions within organizations. So organizations have typically created silos where every division implements their own projects. IT is typically run by the CIO, is well integrated, it's centralized in most organizations. It has seen great progress in advanced cloud architectures and open standards, allowing innovation to happen at a pretty rapid pace. OT, or operations technology, on the other hand, tends to be aligned to lines of business, or as we say, LOBs. And often each LOB will run their own operational technology departments, each with their own priorities. To add to that, they might even run independent networks, have independent procurement and independent budgeting processes. All of this leads to a very high degree of fragmentation. Also, adoption of new frameworks such as cloud, agile methodologies, or CI/CD pipelines is much slower in OT as opposed to in IT. This organizational divide and fragmentation leads to more challenges, such as inconsistencies in technical standards, cybersecurity policies, and process guidelines. I think this quote from a report published by McKinsey Digital captures this theme fairly well. As the authors from McKinsey mention in this quote, the disconnect between IT and OT systems can be a major challenge in achieving digital transformation goals. But with the right strategy and technical roadmap, the integration of these two layers can be the key to unlocking tremendous value from existing business processes and become a catalyst for driving major transformation across the enterprise. So let's take a look at some of the examples of how you can achieve ROI from IT-OT convergence. The first value is 15 to 20% reduction in inventory holding costs. Better visibility into production and predictability in performance can significantly help with reducing inventory holding costs. This was achieved by one of our customers. Because of the high rate of production, it would take them anywhere from 3 to 6 hours to add finished items to their inventory, taking up a lot of valuable factory floor space and not having accurate real-time visibility into their inventory levels. By digitizing the manufacturing operations, they've been able to cut down on the latency down to seconds. And now they not only have up-to-date information about the inventory, but their customers can also get accurate visibility into the current status of production. Another area of value potential is in the labor productivity increase. There are a number of areas where factory operators can benefit from automation in some of their routine tasks while cutting down on errors. Using real-time machine data to proactively detect quality issues can help avoid costly rework, increase yield, and improve worker productivity. Similarly, reduction in machine downtime provides clear benefits such as increased yield, better resources utilization, and improved morale. In the interest of time, I won't go into other business value benefits, but it is very clear that IT-OT convergence has more significant business benefits, such as improved cycle time, better forecasting accuracy from improved visibility, and better data sets. And finally, lowering costs for maintaining high quality levels. That is a really important KPI that's also a great value from digital manufacturing. But while the business benefits are many and clear, digital transformation in manufacturing is hard. The ideas surrounding digital manufacturing have been around for more than a decade, and most companies have started digital projects in the past few years. But a vast majority of these projects never made it past the pilot phase. A recent survey by PwC shows that 64% of digital factory projects are still at the beginning phase. There are, of course, companies that PwC calls as digital champions that have been successful in completing their projects and have been able to realize many of the business benefits that I discussed a few minutes ago. So, what are the factors that determine the success or failure of digital manufacturing? A study by McKinsey provides a great list of common reasons why digital manufacturing projects don't scale past the pilot phase. One of the most common reasons is siloed implementations. We spoke about this as part of the IT OT division within organizations. Often, different divisions within a company will take a narrow view of the transformation by focusing on problems faced by a small part of the business or a single site of manufacturing. And they might end up with multiple teams trying to achieve similar results, but with conflicting approaches. This makes selecting the right organizational strategy very difficult, and often the projects cannot scale beyond the smaller set of requirements that they were designed for. Another pitfall is analysis paralysis, where companies spend years on upfront analysis that tries to understand and quantify all aspects of the project before any work can be performed. This leads to fatigue and eventually project failure. Experimentation and prototyping are key to gaining insights, but users about their users and challenges, uh, leading to MVP for maximum business benefit. Similarly, a technology-first approach that makes architectural choices early before clearly understanding business benefits is a definite indicator of project failure. Functional requirements should drive technical architecture rather than the other way around. Finally, the digital transformation space is quite evolving. There are new technology developments, especially in areas such as IoT, machine learning, AI, that can very quickly make certain capabilities possible that were just not possible a few years ago. If you don't adapt to these technology developments, there's a good chance that your competitors will, and potentially making your solution outdated even before it launches. And another big shift happening is in the workforce skills and availability of skilled resources. Digital transformation projects must stay in sync with changing workforce trends to be able to adapt to emerging demands of the incoming workforce. Now, many of these challenges are not easy. The smartest teams can still face these challenges despite their best efforts. But the first step is in acknowledging them and make choices that will better prepare organizations to deal with them when disruptions occur. There is a very good framework that has emerged based on studies of successful digital manufacturing initiatives. The framework is from National Academy of Science and Engineering. It's basically a maturity model that shows us value-based development stages. The model ensures that benefits are visible throughout the life cycle of the transformation instead of having to wait in the end. The model consists of stages such as computerization, connectivity, visibility, transparency, predictability, and adaptability. Uh, the most important stage being visibility. This is the stage where OT data is used to create up-to-date factory digital twins and gives you a complete perspective of what's going on as today. It's more of what we may call a digital shadow because it's showing you what has already happened. The next stage is when this transparency, when the digital shadow becomes a digital twin, and it can be used to analyze and understand why something is happening. In the next stage with predictability, we can run simulations. The simulations can help anticipate conditions and errors, but this requires really good quality data to build reliable models. Definitely a very difficult stage to achieve. But once you get there, the benefits are tremendous. And in the final stage, adaptability is when systems can self-optimize to adapt to changing conditions without requiring any human intervention. Now, this is clearly a very comprehensive framework that can take a few years to complete. So it's important to have a metric that can continuously track progress to make sure you're on track. So what is that metric? Well, that metric is speed in decision making. There is a great quote by Mark Benioff. He says, "Speed is the new currency for business." The goal of manufacturing transformation is to reduce the inherent latencies that exist at the various steps that have to be performed prior to determining the action and performing the action for a business event. With each stage of the transformation model, you should be able to observe reduction in latencies that allow for much faster and reliable decision making. The speed in decision making is the most influential factor in achieving strong ROI from your digital transformation efforts. With that, it's my privilege to invite my co-speaker, Ravi Balakrishnan, who's at the wonderful company. He is responsible for a large number of enterprise applications, including ERP, manufacturing, inventory, among others. Ravi, welcome.
Hey, thanks, Jay. My name is Ravi Balakrishnan. So I work for the wonderful company. I'm the director for supply chain side of things. So just a little brief about the wonderful company. So this is what we do. So you can probably see some of these, the name brands. Probably you would see it in the store. So what we do is we are $5 billion privately held company based in Los Angeles. And then we make we grow all of our fruits and nuts in the Central Valley primarily, and also in Texas, and then some parts of Mexico. So we grow, we harvest, and also we package, and we market to the retailers, the Costco, Sam's Club, Walmart, all of those. So coming into the application landscape, so this is full landscape of our ERP systems. So we went live with our Oracle Cloud ERP with the wonderful Citrus 5 years ago, and then slowly we want to, eventually we want to get all of them into the same single instance, and we are in the journey right now, and we are migrating. And then some of the cross BU platforms are listed below, including the Oracle Transportation Management, and then business intelligence from Oracle, Hyperion, and then Microsoft Power BI. So going into today's session, we want to talk about the smart supply chain within the wonderful company. So we have main 5 pillars. So one of them start with is the physical flow. How do we automate the flow of material from all the way from our ranches into our factory, and then from factory all the way to our consumers? So how do we do that next level of automation? How do we do that completely, without anybody touching it? So that's the physical flow. And then connect the system. So we want to get the best of solutioning in each areas, whether it's manufacturing or ERP or any of the solutioning. But the thing is, we want to connect those things vertically as well as horizontally. So that way we have the better visibility from end to end, because this is really required to making the smart decision on a real-time basis. So the overall process here is make sure it's completely automated, whether it is the shop floor or even in the system itself. How do we do that without somebody touching it? How do we take the orders, execute them, and ship them out, right? That's the level of automation we want to do. In all of this, we want to respond and then quickly get to the market, because this is a competitive advantage. We want to make sure we are ahead of the curve. So how do we do that? With 3 things anytime when it comes to it. We need to improve the quality, improve the safety, at the same time reduce the cost. And we want to make sure the process and technology comes hand in hand when it comes to smart supply chain, because we don't want to leave one versus the other. Both needs to go hand in hand. So with that, I'm just going to talk about 3 use cases, what we did at the wonderful company. So the first use case is we do a batch input, or the bin validation, and then the consumption. So in our processing facility in Delano, California, so we do bring in bins and bins of fruit from the field. So when it comes in, we have to dump these bins into the processing plant. So how do we do that? So we have a bin ID, which has a content and everything at the time of receipt. So when it goes to the container, when it goes to the conveyor, so we read those bins from the OT layer, and then we kind of call the API calls to Oracle ERP and then Oracle WMS. So what it does is it does a real-time validation, make sure the fruit content is correct to the batch, and also make sure there's no mismatch or anything what we are running at that particular point of time. So when that is matched, and then the bin is allowed to process to the next stage. So why is it important? So we have about 10 seconds to make the decision whether this bin is allowed to go or not. Then the call, we need to go to Oracle ERP and back and make sure it's all done. You can see at the bottom the black window, which has all the information, which takes about 2.148 seconds. That's part of our stress test. So that is the time critical factor which we need to do and make sure it is done and it's validated. This is one of the critical ones. As I said, 10 seconds, you take up 2 seconds for validation, and then the remaining 8 seconds to move move the bin into the processing area. So once the bin is validated, then we do make a call to consume that bin into the batch into our ERP. So this is all done touchless, no touching, nothing involved, and it's completely automated. So this is the first use case. Then going into the second use case, which is a very similar one, which is our Fiji plant. So where we used to do the current process, the previous process before this was at the end of the day or end of the shift, they come up with a spreadsheet and paper. They upload these into Oracle ERP. So it's a time when you don't have the real-time visibility and any of the other information in our ERP. So we looked at what is the next level of automation we want to do. We say like, okay, hey, can we get this and integrate with our PLC? So if you look at the bottom one, so we have a palletizer PLC, which brings the quantity in. So as soon as a new pallet is going through the palletizer, so we get that information. And then we get the information from Oracle on the current running batch and everything to the OT layer. So we combine those two, and then we print a label and apply to the pallet by itself. And as soon as the pallet is read, we will make the transaction into Oracle. So really, there's nobody touching it, nothing, and we have a good connection between the PLC and the ERP. So all are happening close to real time, and there's nobody's touching it. So this is the level of things we want to go, and then we work with operation and make sure, we have a close ties with the ERP team, so that way we take the automation to the next level. So that's the second use case. So the third use case is we have trucks coming in for the harvest to pick up fruits and deliver to the customer. So we during peak season, we get anywhere close to 200 trucks. So all of this, the timing is critical, even few minutes. So how do we automate this? So we say like, okay, hey, let's give the information pre-populate with the QR codes well in advance with an appointment. And then when the truck comes in, we scan that QR code, which has all the information. Then we make the real-time call to our ERP layer, which is WMS and then truck management system. We make those validations and make sure the driver is here with the right information to pick up the right load. And then we release the wave to the shop floor to pick up the pallet and then come to the dock. And then they are all assigned to your dock. And then the truck pulls in, we load the material, and then it leaves. So this is a significant, time reduction, especially when we have like 200 trucks coming in at peak time. So even a few minutes makes a big difference. So this is live now, and with all the OT layer talking from scale to the gate to the ERP, it's all done real time. So with that, I'm going to hand over to Jay.
Thank you, Ravi, for all those very valuable insights from experience with integrating OT and IT at the wonderful company. Truly remarkable to hear about your strategic thinking as well as progress in all of these use cases, and also in avoiding many of the pitfalls that we discussed earlier. For the rest of this session, I would like to discuss how Oracle Fusion can help customers in their journey and minimize the risks while ensuring the fastest time to value. So let's start with a bird's eye view of our supply chain and manufacturing cloud portfolio. In this era of digital transformation, the products and services we offer and the way we deliver them are all being transformed as well. We still need to continue to be efficient, maintain our dedication to quality, promote agility, but that's no longer enough. To succeed, we need a more intelligent supply chain. Oracle's Intelligent Supply Chain Cloud gives you smarter ways to detect problems and opportunities within and outside the enterprise, decide the best course of action, and execute end-to-end business processes that can address those challenges. More specifically, we need to help our customers be more agile in their decision making. As we mentioned, speed is the new currency of business, and reduce the latencies that exist between the occurrence of an event and the corresponding actions. While the scope of this extends across the entire supply chain, for this session, we'll focus on the role played by IT/OT convergence to increase the speed of decision making, and specifically how Oracle's IoT intelligent applications help with that. So let's take a closer look. The primary goal of Oracle IoT Intelligent Applications Cloud is to help break down the boundaries that exist between OT and IT systems. This process can be broken down into 3 steps: integrate, discover, and execute. The first step is to integrate the OT assets, such as equipments, factory floor spaces, operational processes, and other operational entities in the manufacturing workflow to gain a real-time cockpit view of the entire operations. After that, the data acquired from the different operational components is analyzed in near real time to discover insights such as machine faults, operational status such as work order completion events, operational anomalies such as increased cycle time, and quality issues, among many others. Finally, the insights are fed to a rules engine that can automatically determine the actions, if any, that must be performed for the events. These actions could include work order completion updates to manufacturing cloud, machine breakdown events as maintenance work orders, or production schedule replanning because of unplanned downtime. It's also important that there is a closed loop learning available that allows discovery to improve as more actions are performed and results better understood. Uh, I want to take a deeper dive into the area that is most critical for IT/OT convergence. A critical step for IT/OT convergence is ensuring a secure real-time data exchange between OT and IT. This problem, as many of you may be aware, has not been trivial because of the fragmentation that exists in industrial connectivity space. There are a wide range of industrial protocols, many of them purpose-built for specific use cases and industries. But the progress in the digital transformation space has acted as a catalyst for industrial OEMs to rally around a few connectivity options, such as OPC UA, Modbus, MQTT, and HTTP REST. Oracle IoT Intelligent Applications support connecting to industrial equipment and industrial software directly over these protocols, enabling a simple way to establish bidirectional connectivity. For equipment that don't support these protocols, there are other ways to read data. We support base64 binary, CSV, JSON data formats. Oracle also has a wide range of ecosystem partners that provide specialized industrial gateways for fieldbus protocols and other industrial protocols. But data acquisition is just the first step. The next step is to construct a digital twin that can be used as a digital representation of the equipment. Oracle IoT apps allow for modeling digital twins for any kind of equipment using a no-code user interface. Real-time data from the equipment can be directly mapped into attributes of the digital twin, enabling a real-time view as well as the historical visualization of the telemetry data from that equipment. Now, as you may know, different machines produce data at different rates. Some may produce data every millisecond, while others may produce data only once a minute. Even within the same machine, some attributes may sample at rates of, say, 1 hertz, while others could be at 1 kilohertz. So how do you handle these different data rates and ensure that you don't miss information hidden in that data? Sending data to the cloud for multiple equipment at 1 kilohertz frequency might be too expensive as well. This is where edge computing can help. Oracle IoT applications includes an IoT edge gateway that can run on a wide range of off-the-shelf Linux-based industrial IoT gateway hardware, making deployment really simple. The Oracle IoT Edge Gateway is built on a containerized environment that allows for remote deployment and configuration of container services, making it easy to scale from one to tens or hundreds of gateways within no time. But the other important aspect is discovering analytical insights. And this is a huge area of focus for us. We have been working hard to make it easy for our LOB users to leverage the latest innovations in machine learning and AI to drive efficiency in their day-to-day work. Some examples of capabilities that can help drive amazing new insights that can be very difficult to achieve via manual analysis. The first one is correlation analysis that allows for correlating operational data, such as machine data and quality data, with production configuration data, such as operators, material, etc., to identify correlations. For instance, what factors correlate the most to, let's say, product quality? It could be material type, uh, whether the raw material comes from supplier A or supplier B, or the machine health, where what are some configuration parameters that are used to calibrate the machine, and how does that affect your product quality? One of our customers found that the product quality is directly correlated to the raw material grade above all other production variables. So now they already had an idea that this was happening, but having the actual insights reflected in your data from all the historical data that they've gathered, it's a great validation for efficiency in their decision making. Similarly, we use advanced time series algorithms to perform multivariate analysis of machine data to understand conditions that can lead to machine failure or performance degradation. Another great example is how we use AI to optimize preventive maintenance schedules. We use historical performance and uptime data of machines to forecast a time to failure. This time to failure metric is then compared to the actual preventive maintenance window to find an optimal maintenance interval. So we ensure that there's maximum utilization of equipment, and then using constraint-based optimization, automatically schedule new maintenance appointments. There are many other amazing pre-built analytics capabilities that we don't have time to cover, but we can definitely talk to you in a product briefing. With that background, I would like to quickly discuss how one of our customers has successfully used the Oracle Fusion product suite to drive their digital transformation agenda. Allcar is an internationally active industrial and commercial group which places its strategic focus on steel and alloy wheels. They're in a highly competitive market, and they need to find new ways to improve productivity and visibility to stay ahead. They needed a scalable and a flexible and integrated system to support planning, sales, procurement, and other operations, such as even manufacturing. Many of the production and maintenance transactions were manual and time consuming, even though the production was automated. And because the data was manually collected, and not always real time, Allcar execs didn't have the real time visibility into their company operations. So the solution they implemented enabled them to do real-time monitoring of shop floor machines and production reporting with IoT production monitoring. It also helped optimize preventive maintenance to keep the shop floor running at capacity without unexpected downtime. So basically, through their digital transformation journey, they have realized some of the metrics, some of the KPIs we discussed earlier, enhanced productivity, improved user experience, increased flexibility and control level of the manufacturing process, and better visibility. So going back to the same ROIs that we discussed earlier, there are many examples of successful ROI from many of our customers. So just an example of what folks have been able to achieve using Oracle Fusion products in their manufacturing transformation, digital transformation initiatives. We're almost at the end of this session. So I'd like to frame all the topics around OT/IT integration and frame them in the context of the entire digital thread for manufacturing. Oracle Supply Chain Execution Cloud, which is a part of the entire Oracle Supply Chain, Fusion Supply Chain Cloud, covers the workflow as shown here from the product design to supply chain planning to manufacturing, production scheduling, quality, maintenance in a closed loop model that allows for continuous improvement. With all these capabilities that extend from the OT environment all the way to the IT environment, Oracle Supply Chain Execution can help customers throughout their digital manufacturing journey. We believe this eliminates the need for expensive on-prem MES. That may no longer be required because Oracle Supply Chain Execution can cover all aspects of the manufacturing workflow. This brings me to the end of our session. Thanks for joining, and I would also like to thank Ravi for sharing his excellent insights. As parting words, I'd like to remind you on why Oracle is your partner in digital transformation. The company culture is focused on understanding and helping customers and co-creating products in an agile manner. We have a strong OT/IT integration solution using our Oracle IoT applications, and we're doing a large amount of investments in building a suite of capabilities to drive strong digital transformation roadmap for manufacturing. We would love to have you as partners in this journey. Thank you again for joining this session.